Hello engineers and welcome back to Civil Nirman. Ever open your STAAD model and suddenly you got a warning saying FYLD removed from the direct analysis. Now if that left you confused or worse, worried if your analysis is still valid, this video is exactly what you need. We are going to break it down step by step, show you what changed, why it happened, and what you should do to make sure your results remain reliable. So let's simplify this. So even if you are new to STAAD or direct analysis, you will live with full clarity. You can check out this particular STAAD warning. See, this message is now part of the analysis output starting from STAAD.Pro version 22.07. You can check out this version here. See, in earlier versions, we used to specify FYLD, the yield stress, directly inside the direct analysis command block. But that's changed. Now, STAAD simply ignore this FYLD in that particular command. Why? Because STAAD already reads FY, that is your yield stress, from the material definition itself. Now, duplicating it inside direct analysis, it becomes redundant. So what do you need to do? So here is the key action. See, make sure the yield strength is correctly defined in your material section. Another most important thing, when you define your material, include FY explicitly. See, that's what STAAD will now use for direct analysis. And if you forget to define it, STAAD will assume default value of 36 KSI, which is approximately 248 megapascal. Now see, that might not be what your design actually needs and could lead to incorrect stiffness reduction in direct analysis. So define it clearly. Now let's understand the impact on the steel design codes. So let's take this step further. If you are also performing steel design, especially with the codes like AISC 36016, the software will look for FYLD and FU values in your design parameters. But here is the trick. See, not all codes automatically pull FY from the material definition for design. So to avoid any code mismatch or design error, it's good practice to explicit the define FYLD and FU under the design parameter section. And that way, your analysis uses the correct yield strength and your design uses the same, keeping everything consistent. So here is the quick summary and one practical tip. First, do not include FYLD inside the direct analysis command anymore. Second, ensure FY is correctly defined in the material definition. If FY is missing, STAAD defaultly use 36 KSI, that is 248 megapascal, which may be incorrect for your project. Fourth one, for design, define FYLD and FU in your design parameters block, especially if your design code doesn't pull from materials. And here is the bonus tip. See, update any older templates or macros that still include FYLD inside the direct analysis command. That line does nothing now. Now see, warning like this can seem minor, but in structural engineering, small inputs can have big impacts. See, understanding changes like this help you design safer and more reliable structures. Now, if you found this breakdown useful, hit that like button and consider subscribing for more simplified STAAD and structural design insights. I'll see you in the next video. Now, if you got another STAAD warning or code confusing, drop particular that in our comments and we will cover it in our upcoming video. Remember, don't just learn software, learn concepts. Thank you.